Okay, hi guys. So in this lecture, we'll be discussing on adiabatic ideal gas expansion compression. So let's get started. Adiabatic ideal gas expansion compression. Okay. So we'll be seeing process here. Then delta S of system. Delta S surrounding and delta S total. So first process we have is reversible ideal gas expansion. Okay, and delta S system for it would be delta S would be NCVM ln T2 upon T1 plus nr ln V2 upon V1. This formula we have already discussed and derived in the previous lectures. Okay, so here this term would be this would be equals to 0. Why this would be equals to 0? Because we know that delta U is Q plus W. Okay, and delta U minus W would be equals to Q in other words. Okay, now if this is the case, then what will happen? Delta U minus W is equals to Q. Okay, so now minus W equals to Q. So now we know that it's a reversible process. Okay, and Q can be written as, this is nothing but delta W by T integrated, du by T integrated, and this is dW by T integrated. So this would be equals to Q, and Q would be equals to 0 because this is a adiabatic process. Hence this term would be equals to 0. Delta S surrounding would also be 0. Delta S total would be 0. Next, let's talk about irreversible ideal gas expansion, and let's take two scenarios. First scenario is we have free expansion. So in case of free expansion, what would be the case? In case of free expansion, temperature would not be changing. Hence we can directly write delta S would be equals to nr ln V2 upon V1, and V2 would obviously be greater than V1, so this quantity would be greater than 0. Delta S surrounding would be 0. Hence delta S total would be delta S system plus delta S surrounding, that would be greater than 0. If we take another part in this, that expansion against some pressure. Okay, so here P external would not be equals to 0, unlike in the free expansion case. So delta S can be written as NCVM ln T2 dash upon T1. T2 dash is the temperature of irreversible expansion, or the final temperature of the irreversible expansion, plus nr ln V2 upon V1. So please see that in this term and in this term would be acting as a positive term, and this term would be acting as a negative term. Okay, to balance each other out, and would be 0. But in this case, this term would be positive term. Why? Because we know that T2 dash, or rather T2 dash, which is nothing but T irreversible, would be greater than T2, which is nothing but T reversible in adiabatic process. Okay, and why would this be the case? because we know that delta u is equals to q plus w. Okay, so for a reversible process we can see that we can write delta u would be equals to, or rather ncvm dt dt would be equals to, this would be minus p dv. So just substitute the value of p here. Q would be 0, so p value would be nRT upon v dv. Okay, so here we can write ncvm dt upon t would be equals to minus nr dv upon v. Okay, so after integrating it we get that cvm ln t2 upon t1 would be equals to minus r ln v2 upon v1. Okay, this was the case for irreversible reactions, and for this was the case for reversible reactions, and for irreversible reactions we can directly write that delta u would be equals to w, and w would be nothing but minus p external times dv. So this would be ncvm dt. So when we integrate it, so this is nothing but, this would be nothing but minus p external v2 minus v1 okay, and this would be ncvm dt. Now just let's have a look here, then how do we compare these two terms. So we know that p external would be less than p, which was p in case of reversible. Okay, reversible process, so p external minus of p external would be greater than minus of p. Okay, so this implies that minus p external would be greater than, what would the value of p? Value of p would be nRT upon v. Okay, so let us rewrite it something like this. Instead of going this approach, we can directly tweak it, that minus p external times dv, and we know that minus p external is greater than, so this value. So if we multiply both the sides with dv, so it would be greater than minus nRT dv. So now we know that minus p external dv is equals to n cvm dt. So n cvm dt, which is the value of minus p external dv, would be greater than minus nRT upon v dv. Now just integrate on both the sides and then get cancelled. Shift t to the denominator of LHS, so we will be getting cvm dt upon t on integration would give us minus RT upon v dv. Okay, so let's mark it that the final temperature in this case was T2, and final temperature in case of irreversible process was T2 dash. Okay, so it would be going from T1 to T2 dash, and volume ranges would still remain the same. So this would be cvm ln T2 dash upon T1. So this implies this would be greater than, we saw this symbol here, this would be greater than minus RT ln v2 upon v1. Okay, mark this as second equation, and we already have first equation, that cvm ln t2 upon t1 is equals to minus r ln v1 upon v2. So just put the value of minus r v1 upon v2 as cvm ln t2 upon t1 from the first equation into the second equation. So we get cvm ln t2 dash upon t1 would be greater than cvm ln t2 upon t1. cvm and cvm get cancelled out, so we get t2 dash would be greater than t2, or in other words t irreversible would be greater than t reversible in case of adiabatic process, which we had already written here. Okay, so what does this imply? So as t2 dash is greater than t2, if you look at this term, which is delta S equals to n cvm ln t2 dash upon t1 plus nr ln v2 upon v1. So we want to know how this term is greater than 0. So if we look at this term, So we can write that nr ln v2 upon v1 plus nr plus ncvm ln t2 upon t1 is equals to 0. So from here I can write that nr ln v2 upon v1 can be written as minus ncvm ln t2 upon t1. Just used this, we can just use this result into this equation, that nr ln v2 upon v1 can be written as, so this term can be written as ncvm, I'm just writing first this term, ln t2 dash upon t1 minus ncvm, the value of nr ln v2 upon v1 would be minus ncvm ln t2 upon t1 minus ncvm ln t2 upon t1. Okay, so now we know that t2 dash is greater than t1 t2, so we can see that this term would be in fact greater than 0. Okay, hence this term would be greater than 0 and delta S surrounding would be 0 because this is the adiabatic process. Hence delta S total would also be greater than 0 for an irreversible ideal gas expansion under against some pressure. Okay, so with this we come to the end of this lecture. I hope you have all followed this. So we'll meet in the next lecture. Till then, good luck and goodbye.